This video is about the real number line for Math60. I'm going to look at two key ideas here. The first is inequalities, and the second absolute value. So before we get started on that, let's just look at the real number line. We talked about sets of numbers before, sets of integers. Now we're going to look at putting those on a line. So there's a line. And I'm going to actually let that line go all the way to the left and all the way to the right. And I'm just going to place on this line all the numbers that we had. So we had integers. First of all, we started, remember, with natural numbers, so we started counting. We had 1, 2, 3, etc. And this would continue on all the way. They're sort of equally spaced. And then we added the number 0, and they became whole numbers, so they all sit on this line. Then we added negative numbers, negative integers, like -1, -2, -3. And what this does is it sets up an ordering in the numbers, where we go from left to right, negative to positive. If I have 1 of something, and you have 3 of something, then clearly you have more than I do. And I would say that I have less than you do, or 1 is less than 3. That makes sense. What we do is we put a symbol, looks like that, and that's 1 is less than 3. And the less than symbol, less than, is given by this sort of sideways V. We could also write 3 is greater than 1. And that makes perfect sense. It gets a little more difficult when we're looking at the number line and we're saying -3. Is -3 bigger or is it smaller than -1? Hard to sometimes tell, but if we think about the number line, the numbers that are less than the others are to the left of the numbers. So -3 is to the left of -1 on the number line. Hence, -3 is less than -1. So this is to the left of this number. So -3 is left of -1. Therefore, it's less than -1. Now on this number line we can also add real numbers. This is actually the real number line, sometimes considered a capital R. So on this real number line we know there are fractions as well. For instance, where would we put 1/2? Sure, between 0 and 1 we would have 1/2 sitting right here. Right? So we can put all the numbers onto this number line. It's very dense. It has a lot in it. The number pi is an interesting number. It's irrational, remember. But if you put that into a calculator, you'll find it's approximately 3.14. So that means it's certainly bigger than 3. Right? So pi is greater than 3, or I would read this 3 is less than pi. But pi is also less than 4. So this is basically telling me that pi is between the numbers, between the integers 3 and 4. If I put that on the number line, it would show up somewhere here, right? A little bit closer to 3 than 4, but this would be the number pi. All right, these signs right here and here are called inequalities. So let's take a closer look at that. If I said 5 equals 5, that's a true statement, right? 5 certainly does equal 5. 4, however, does not equal 5. It's less than 5. So it's not equal to 5. It's an inequality. There's some sort of ordering or sequence to this. But I can also say in mathematics that 4 is less than or equal to 5. 4 is less than, and then there's big or, equal to 5. And if either of these are true, then this is a true statement. So 4 is less than 5 is a true statement, and 4 is less than or equal to 5 is also a true statement in mathematics. These are called inequalities. So inequalities do not have an equal sign. They have one of these: less than or equal, greater than or equal. Okay, so let me give you an example. Let's say we had two numbers. Let's say we had -3 and the number 10. And I said, all right, I'm going to give you these two numbers, and I want you to put them in the correct location in this particular inequality. So what is greater than or equal the other? Which one goes in which location? Which is the larger number? One way to look at this is to say, well, where do they fit on the number line? Here's a number line. Oops. Here's a number line going either direction. -3 would be here. Then I go -2, -1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 would be over here. So 10 is to the right, which means it's a bigger number. It's greater than -3. So 10 would be greater than -3. One of the ways I remember whether it's less than or greater than, depending on which way I'm reading it, is this is a smaller point, and this is the sort of large opening. So this is the greater than, this is the less than. So if I read it in this direction, I would say 10 is greater than or equal to -3. Sometimes we read them in the other direction. If I read it in this direction, now I'm going -3, and I come across right to left, and I say is less than 10. So I could write it like this: -3 is less than or equal to 10. Another symbol that shows up with a number line is the symbol for what's called absolute value. So here's a number line. Here's 0, and I'll just space it out: 5, 10, 15. Just put some scale onto this number line: -5, -10. So these negative or positive numbers, we omit the plus. We just assume positive if there isn't a sign. They tell me where the number's located, either to the left or to the right. Let's say I told you I got in my car and I went 200 miles. You'd say, great, good for you. However, I haven't told you where I went. Now I live in Eugene. If I told you I went 200 miles north, you'd say, oh, you went to Portland. So I gave you more information. Here I just told you 200 miles. We have no idea where I went. Somewhere from Eugene, 200 miles. However, if I tell you it's north, you know I went to Portland. So on a number line, sometimes we don't really care the direction. We just want to know the distance. Let me see if I can erase this. And of course, mathematically, we have a special symbol for that. But let's take a look at this number line. If I go from 0 to 10, I've gone 10 units. 10 inches, 10 whatever, right? 10 miles. From 0 to 10, there are 10 little units in here. 1, 2, 3, 4, right? 10. But I could go the other direction. We could call this north and this south, right? Or west and east, however you like it. This is also 10 units. If I told you I went 10 units from 0 to the right, you'd know I would be at 10, and if I told you I went 10 units from 0 to the left, you'd know I'd be at negative 10. But if all I care about is how far I went, then I have just 10. Absolute value is what we use just for the distance from 0. From 0 is important. So that means the distance, say from 0 to 10, would be 10 units. The distance from 0 to negative 10 is also 10 units. This symbol is what we use. Two vertical lines going straight up and down surrounding a number is what we use. This is the symbol for absolute value. Now notice that this negative got changed to a positive. So whatever I put into this absolute value, since I'm dealing with distance, will always come out positive. The absolute value of negative 20 is equal to 20. The absolute value of 5, it's already positive, it's the distance of 5. Right? The absolute value of negative pi is equal to pi. So in absolute value, whatever number we put inside these absolute value bars will always come out positive.